Welcome to the lecture series for MLT 115, Laboratory Calculations. In this course, you'll be learning a lot of mathematical concepts that will help you in the medical laboratory field. In this particular section, Chapter 1, we'll be going over basic mathematics. Some of this might be review, but we need to make sure that you're familiar with it in order to be successful in the laboratory. The first concept that we're going to cover are just different numbers and numeral systems that are out there. You need to be familiar with the differences in the numbering systems in the laboratory. First, we have the most familiar one is the Arabic system, and these are just your regular numbers like 1, 2, 3, 4, and so on. And then there's the Roman system where it uses the Roman numerals. If you're not familiar with writing Roman numerals, you'll want to become familiar with your Roman numerals. And then the third system is the Greek numbering system. And you can see those examples here along this line. And we use this a lot, especially when we're talking about the structure of hemoglobin. When you're in hematology, we'll refer to different chains in our hemoglobin structure. You'll have an A chain, B chain, and so on. So you need to make sure that you're familiar with all three of these numbering and numeral systems so you'll be able to refer to things in the laboratory. And something of note, the Greek and the Roman system have no zeros. Your Arabic system is the only one that includes a 0. So our Arabic numbers are used for calculations. Next, we need to be familiar with the binary system. The binary system is used in computer systems and laboratory systems. It's usually a combination of zeros and ones that allows a computer system to understand or to identify something. And it's important in the laboratory field because we use this to identify patients, samples, things like that. So a lot of times we use a binary system for a patient's MRN number or their medical record number. So you have patients come into the hospital or doctor's office, but in particular hospital, and they'll get an armband. Well, that armband will have a barcode on it, and we'll use that barcode to scan and identify that patient. So that's all part of the binary system. Being able to use the binary system and these barcodes and specific identifiers for patients, it helps eliminate errors in the hospital system and the laboratory. Okay, we also need to know about fractions. I know we all probably learned about fractions in middle school, but we need to make sure that we remember how to work with fractions and the terminology that goes along with fractions, because fractions are very important in the laboratory setting. So let's look at some examples on this slide. If you divide this circle into 4 different parts, just one part would be a fourth. Okay, so 1/4. But let's look at the dark blue section on this circle. They've got 3 parts darkened out in dark blue. So you got 1/4, another 1/4, and another 1/4. So that would be 3/4. Okay. Well, let's say we want to know the whole of the circle. So let's put it all together. So here's 1/4, and then we know we've added these 3 together already. So that's 3/4. So your 1/4 plus 3/4 equals 4/4. So that's the total circle. Well, 4/4 is the same thing as 1 or 1/2. Let's look at the cylinders over here on the right-hand side as a second example. We've got our cylinder divided up into 4 different parts, and 2 of the sections are darkened with the dark blue color. So what does that tell us about the cylinder? How much of the cylinder is filled out with that dark blue? So we have 1/4 plus 1/4 equals 2/4. Well, when you reduce that down, 2/4 is the same thing as 1/2. So 1/2 of the cylinder is darkened out with the dark blue. So you can see for comparison, 2/4 is the same thing as 1/2. Now let's review some nomenclature of fractions. How are things named within fractions? So let's look at what the top number is called. The top number is called the numerator. The bottom number is called the denominator. Okay, so the numerator and denominator can also be written as the numerator divided by the denominator. So this line can also be looked at as a division. If the numerator is less than the denominator, then it's known as a proper fraction. An example would be 3/4. If the numerator is more than the denominator, or the top number is greater than the bottom number, it's known as an improper fraction. If there's a whole number in front of the fraction itself, for example, 5 is in front of the 3/4, it's known as a mixed number. Equivalent fractions are fractions that have different numerators and denominators, but they ultimately represent the same value. And then finally, decimals are just fractions represented with a decimal versus in fraction form. For instance, the example of 0.5, that's the same thing as 1/2. Or the 1 being over the 2, the 1 being in the numerator spot and the 2 being below in the denominator spot. Okay, let's make sure that we know how to do some calculations with our fractions. Let's first do some addition and subtraction. Let's look at some examples of adding and subtracting some fractions with the same number for the denominator. So let's look at this first example. We have a 9 and a 9 for the denominator. So in that case, for adding and subtracting, you can just move that denominator over. So in our answer, we end up with the 9 in the denominator spot. Well, for the numerator, you can just add your numerators together because we're doing addition. So 3 plus 2 is 5. So we end up with 5/9 as our answer. Okay, let's look at an example for subtraction. Again, our subtraction example, you have a 9 and a 9 in the denominator spot, so we can just move that over. In our answer, you end up with 9 in the denominator spot. But again, we're doing subtraction in this particular example. So we're subtracting our 2 from our 3. So 2 from 3 is 1. So our answer is 1/9. Okay, on the bottom half of the slide, we're going to use equivalent fractions with the same denominators. And again, we're adding and subtracting, but we're going to have to do something to the denominators to make them the same or the same number. So we're going to have to manipulate them in some way. And the way that we're going to manipulate them is we're going to multiply them by a number. So let's look at this first example here. Okay, so let's just look at this part right here is what we're looking at. So what can we do to this denominator and this denominator to ultimately make it equal 6? Let's think about that for a second. Again, I said we're going to use multiplication. So what number could we multiply these numbers by to get them to be a 6? Well, 2, we can multiply it by a 3 to get it to be 6, right? Well, if we multiply the bottom by 3, guess what? We got to multiply the top by 3 as well. Okay? To get the 3 to be a 6, we got to multiply it by 2. Well, again, we've got to do the same thing to the top of the numerator. So now we end up with 3 6 and 2 6. So now our denominators are the same. So can we add them together? Yes. Again, the 6 can be moved straight over. So 3 plus 2 is 5. So the ultimate answer is 5 6. Let's look at our last answer. Again, we've got to manipulate our denominators by multiplication to get them to equal 20 in this case. So what can we do to our 4? We can multiply it by 5 to get to equal 20. Well, we need to do the same thing to our numerator. So that's going to be 15. So it's going to be 15 over 20. Okay, what do we need to multiply our 5 by to get it to be 20? 4. And then we need to multiply our numerator by the same number. 2 times 4 is 8. So we're going to end up with 8 over 20. We can go ahead and move our denominator over because we've got it the same. So there's our 20 moved over. And again, we're subtracting in this particular example. So what is 8 minus 15? That's 7. So our answer is 7 over 20. Okay, let's look at some more calculations with fractions. Let's look at an example of multiplication. So with multiplication, you don't have to worry about getting your denominators the same as with addition and subtraction. So let's look at this first example here, and we're going to actually work it out down here. So you can actually work straight across. So when I say straight across, I'm meaning straight across like this. So 4 times 1 is 4. 7 times 8 is 56. So our ultimate answer is 4 over 56 for multiplication. For division of fractions, it's a little bit more complicated than multiplication, and I'm going to give you a little trick to help you remember how to complete the calculation. And the trick is leave me, change me, turn me over. Okay, so what does that mean? So in this example here that we're going to do, the leave me would be the 1/2. The change me would be the division, and the turn me over would be the 4/3. Okay, so when we do all that to this equation or this calculation, what is it going to look like? If you leave me, you're going to leave it as 1/2. If you're going to change me, we're going to change the division to multiplication. And then turn me over, we're going to flip this. So we're going to turn this into the reciprocal. It's going to go from 4/3 to 3/4. So then we can solve the equation or the calculation just like we did over here when we were doing multiplication, and we can just solve straight across. So 1 times 3 is 3, and 2 times 4 is 8. So our answer is 3/8. Let's talk about decimal fractions a little bit more and how they are expressed. Okay, so let's look at this number, 3,915.807. Okay, so when we're talking about what is the number in what position, the 3 would be in the thousands position. So the 3 would be in the thousands position. The 9 would be in the hundreds position. The 1 would be in the tens position. The 5 would be in the units position. Of course, the decimal is in the decimal position. The 8 would be in the tenths position, the 0 would be in the hundredths position, and the 7 would be in the thousandths position. So there's a proper way to read these decimal fractions off when you're saying them verbally. So let's look at a couple examples. If we're just looking at a number that's in the tenths position, such as 0.8, it would be 8 tenths. Another example would be 0.807. If you were reading it off, it would be 807 thousandths. So we know we can change our fractions to a decimal form, but we also can change our decimal form to a percentage form by moving our decimal. And also something we need to know, our percentages are per 100. Okay, so let's look at this first example. We've got 45 over 100. And remember, our percent is per 100. So our 45 is over 100. So in order to get our decimal, to get 0.45, what did we have to do? We had to divide. Remember, we said this line can be the same thing as division. So if you divide 45 by 100, you can get 0.45. Okay, now we want to convert this 45 to a percentage. So how do we get 0.45 to a percentage? Well, we have to move our decimal. We're going to move it 2 spaces to the right, and we're going to end up with 45%. In this next example, they give us 8 over 100, and they give us the percentage instead of the decimal, so we have to find the decimal. Okay, so how are we going to find the decimal? Well, the decimal, where is it located in the percentage? It's located at the end. Okay, well, which direction do you think we're going to move that decimal? We're going to have to move it 2 spaces to the left. Okay, so what's the answer for the decimal? It's going to be 0.08. It's going to be the answer for the decimal. For our last example, they give us 150 over 100. Again, they're giving us the percentage, and we're going to have to find the decimal again. So, again, where is the decimal located? It's located at the very end of the number, and we're going to have to move the decimal to the left 2 spaces. So we're going to end up with 1.50 as our answer. And you don't have to put that 0 at the end. It can just be 1.5. Okay, so let's look at some more examples. They give us 1,055 over 100, and they give us the percentage, and we need to change that to a decimal. So where's our decimal located? It'd be located at the very end, and we need to move it over 2 spaces to the left. So for a decimal, that would give us 10.55 for an answer. The last example is already worked out for us, but let's go over it. It's 0.07 over 100, and your decimal is 0.0007, and your percentage is 0.07%. But how did they get to that 0.07%? Again, they would have to move their decimal. Their decimal's here, and they're going to have to move the decimal to the right 2 spaces, and you're going to end up with your 0.07%. So if you're going from a decimal to percent, you're going to be moving 2 spaces to the right. If you're going from a percentage to a decimal, you're going to be moving 2 spaces to the left with your decimal. Let's do some calculations with percentages in them, and it's easiest to convert your percentages to decimals when you do these calculations. So let's look at our first example. We have 55% in this particular calculation. So how do we convert our percentage to a decimal? Well, we need to convert. So we know that our decimal is at the end. So we need to move it over, our decimal over 2 spaces to the left. So we end up with 50.55 plus 2, and then we can just do our addition like we normally would. So we end up with 2.55 as our answer. The next example is using 75 in the calculation. This time we're doing subtraction. Again, we need to move over our decimal in our percentage to get a decimal number. So we move over the point in the 75% 2 spaces to the left to get 0.75, and then we can do the subtraction as we normally would. So 0.75 minus 0.5 would be 0.25 is our answer. In the third calculation, we've got 25%. We need to move our decimal over from the end of that number. So if you move it over 2 spaces, you end up with 0.25. And in this problem, we're doing multiplication. So 0.25 times 48 is 12. In our last example, our percentage has the decimal within the number. So we grab our decimal wherever it is and we move it over 2 spaces to the left. So our decimal is 0.015. And then this calculation, we're doing division. So divided by 3, your answer is 0.005. This concludes part 1 of the basic mathematics lecture. I'll see you over in part 2 where we'll talk about things like number lines, significant figures, and order of operations.